So this is a question from which year was this? June 2016 or 17 was it? Wait, let me check. Okay, I have no idea which year question is this. A ball is dropped and reaches the ground after 0.42 seconds. So remember, you are dropping the ball, okay, from the maximum height, and if this is the ground, it drops after 0. This is exactly the same scenario which we studied, okay, from the first part of the video. The ball is dropping down. The ball bounces and is caught at the same height. Now this is very important. In the explanation part of the first part of this series, this motion of a bouncing ball series which we are making, or I think this will be go into the practice part most probably. So I will actually no, this will be different. Okay, yeah, first part of this series only. Yes, first part of this motion of bouncing ball series. What happened was the ball could not reach the maximum height like previous. Why? Because there is loss of energy. Okay, because the ball lost the energy to the surrounding. Niluma, that was the answer I was expecting from you. The ball loses the energy to the surrounding in the form of sound and heat. Okay, but in this particular case, we are assuming that it is a key. Where it is not dropped, it is dropped, it is not thrown. You're not throwing the ball downwards, you are dropping the ball. You're not projecting the ball downwards. Okay, so it should not, technically it should not go to the same height, but here we are assuming that it is caught at the same height. We are assuming that it is caught at the same height. Okay, okay, then that means what will be the zero at the maximum, sorry, what will be the velocity at the maximum height? Zero. So that means somehow my graph should come back to zero. Okay, the graph should return back to zero. Now after that, what happens? What else is there? Nothing. Okay, let me rub this. This was the explanation. Okay, now draw on the graph, excuse me, let me cancel this. Draw on the graph paper below the velocity time graph for the ball of the motion of the ball. You may assume that the time taken the collision with the ground takes, and all the frictional forces are negligible. See, when you assume this, that the collision of the ground is negligible, you know what happens? When we draw a velocity time graph, my velocity time graph bouncing is perfect. Can you see this is a perfect vertical line? Remember, we did these graphs, na? Hey, Ashfaq, please notice this. Everyone else, you see these are vertical lines. Bhaiya, doesn't the ball take some time to bounce? So in reality, if you have seen my previous videos, you will notice that I mentioned there, in reality, when you take friction and time of the collision into account, your graph actually should look like this. But how are we drawing? We are drawing it perpendicular, perfectly perpendicular line we draw, which is not correct, because ball does take some time to bounce. It takes its time. If you have slow motion cameras, and I think in internet, YouTube, a lot of videos are there, you can just go and check. A ball presses the ground pushes the ball, the ball compresses. So there is a lot of going on in that fraction of a second. Yes, the time is very less, but still there is a significant time it takes to bounce. But we assume that the bounce is instantaneous. That's why we draw this vertical line, and that's what they're saying, that even if you draw vertical lines, it's okay. Okay, so is the explanation of the question understood? Everyone, is the explanation understood? Husnera, Niluma, Shenas,
Yes.
okay, everyone, Junera. Now, so when the ball is dropped from the maximum height, just before it hits the ground, it will have a maximum velocity. Yes or no? It will have maximum velocity. So let us find that maximum velocity. What is it? V equals to, okay, U plus AT. What is the maximum velocity? Final velocity?
Will it come down on the graph?
I will explain everything. Okay, just focus in this part first. What is your initial velocity? 0, because you are dropping it. They use the word drop. That means rest, from rest. Okay, what is your acceleration? 9.81. How much time did you take? 0.42 seconds. Okay, Okay, another assumption you should know, you should make that, look, when the ball is hitting the ground, after hitting the ground, it will take exactly the same time it took to drop drop to the ground. What is the time it took to drop to the ground? 0.42. What is the time it take to reach at the maximum height? 0.42. Remember that. Okay, because every condition is same. Okay, so what is the answer you're getting? Maximum velocity 4.12. 4.12 meter per second. Okay, so what is the total time taken of the journey? What is the total time taken off for the journey? 0.42 multiplied by 2. How much is it? 0.84 seconds. Do you need any other information over here to draw a velocity time graph? Is the velocity time graph is the velocity known to us? Listen, is the maximum velocity known to us? Yes. Is the is the maximum time taken, the total time taken of the journey? Yes, known to us. Understood? Okay, now let's start drawing. So what is it? 4.12, no? Okay, this. Can we write 1, 2, 3, 4? Okay. So the maximum height, okay, and also here also we can do, see, we can draw the graph in a positive, we can also draw the graph negative, both are allowed. Okay, but we will follow what we did in the first video, first lecture. We will take the negative because the ball is going downwards. We will take it negative, -3, -4. Okay, now let's plot. We need what is the time we need? 0.8 now. So can we do 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8? Okay, and what do we need? 0.8, 4. Okay, so 0.
Why did you choose the 3?
Why? I will explain that. Don't worry. 0.81, 82, 83, 84. Here it is. This is my 0.84, and this is 8, 7, 6, 5, 4, 3, 2, 1. Is everything else labeled? Yes. If it is not labeled, make sure you do. Always write the unit and always write the label as well. Okay. At one time is the midpoint of the journey 0.42. Okay. So at 0.42, just before it hits the ground, its maximum velocity is 4.12, right? At 0.42 seconds. So we will go to 0.42. By the way, I forgot to give something. It's going to be 0.1. It's going to be 0.2. It's going to be 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8. Okay. Now we want 0.42, 0.41, 0.42. What I'm going to do? I'm going to go down now. And I want 0.41 from me. Sorry, 4.1 from me. 4.12, 4.1. Almost very similar. So this is the one, this is the point I'm looking for. Correct? But make sure you do not give this point as big as possible. You have to be very careful. It should be a small dot. Okay, 4.1, 0.41, 42. A small cross would do. Okay, then let me take another color. Negative side. Okay, joint the line. Okay, now after this, what happens? It bounces. So remember, whichever speed the ball is hitting the ground, okay, usually it will hit the ground at 4.1. Not usually. In this case, we know, we calculate it will hit the ground with 4.1 meter per second. Also, it will rise up with the same speed but in opposite direction. Here the velocity is negative. Here the velocity is what? Positive. Because your direction change. If the direction changes, your sign of your velocity will also change. Here you know the velocity is negative. We assume that the velocity is negative, and you know slope and all. I taught you in the first chapter. Velocity is negative. It is bouncing. You think, why is it bouncing with the same speed? It is bouncing with the same speed because we are considering that it has reached the same height. Can you see? That means whichever speed it hit the ground, same speed it is bouncing up as well. Online people, understood? Everyone? So it's bouncing. What will I use? I will use definitely a dotted line for bouncing. But if I wanted, I can use a solid line also. That is up to me. But I'm using a dotted line just to show you that that is a bounce. Okay. And by the way, I need to use a thicker line. That would be better. Okay, 0.53 done. This also 0.53 done. Okay, and it will reach till 4.1, right? Then what happens? Then what happens? Solid line again from here till 0.84 seconds. Look again. Let me make the line thicker. Husnera, do you have any doubts to ask me? Form your doubts. And Mir asked me a doubt as well. What was it? Do you understand the graph? Everyone, what I did in this graph. See, this is where the ball is falling downwards. This is where the ball is bouncing. Okay, it is bouncing at 0.42 seconds. Okay, and it reached at what speed did it hit the ground? 4.1 meter per second. Okay, and from 4.1 in the opposite direction. Here your velocity is negative. Your velocity is positive. Since you are changing direction after the bounce, your value of your velocity or the direction of your velocity will also change. So and then it kept on rising up till it was caught. It is rising up till it was caught. Okay, what do you want me to repeat?
This explanation.
See, the ball is falling. It started from 0. It's falling down. Velocity is increasing. Falling down. Velocity is increasing. Falling down. Velocity is increasing. Okay. Before hitting the ground, its velocity is 4.1. After it bounces from the ground, see, this is the bounce. This dotted line is the bounce. After it bounces from the ground, again it start this thing. After the bounce, the initial velocity is 4.1. How is that possible? Because you are caught at the same height. That means we are assuming there is no loss of energy. So when we assume there is no loss of energy, you know that whichever velocity it bounces with, it will bounce up also with the same velocity. Then it kept on rising up. When you rise up, you are decelerating. Rise up, rise up, rise up, rise up, and at one point it was caught. It was caught and the velocity became 0 at the same height. Understood? Is the question understood by everyone? I will stop the recording of this.